Good morning, champs. Today we are starting a new topic in statics, friction. And there is one idea I want to make clear from the beginning. Static friction does not automatically equal the coefficient of friction multiplied by the normal force. Static friction adjusts to whatever value is necessary to prevent motion, up to a maximum value. Only when the object is just about to slide does static friction reach its maximum value. Consider a block with a mass of 150 kilograms resting on an inclined surface. The incline makes an angle of 12 degrees with the horizontal, and the coefficient of static friction is 0.28. A horizontal force acts on the block toward the left. Our goal is to determine the minimum force required to make the block start sliding. Before calculating anything, we need to determine which way the block is about to move. Gravity has a component acting down the incline. The horizontal force also has a component acting down the incline. Therefore, the impending motion is down the slope. Friction must oppose this motion, so the static friction force acts up the slope. Now we draw the free body diagram. Four forces act on the block. The weight acts vertically downward. The applied force acts horizontally to the left. The normal force acts perpendicular to the surface, and static friction acts up the incline. For problems involving inclined surfaces, it is usually easiest to choose local coordinate directions. One direction runs parallel to the incline, and the other direction is perpendicular to it. The weight of the block is the mass multiplied by gravitational acceleration. This gives 1,471.5 newtons. Its component parallel to the incline acts down the slope, while its normal component pushes the block into the surface. Now consider the horizontal force. Its component parallel to the incline also acts down the slope, but its normal component points away from the surface. This is important. The applied force does not only encourage the block to slide, it also reduces the normal force. And because the maximum available friction depends on the normal force, it reduces the maximum friction at the same time. We begin with equilibrium perpendicular to the surface. The normal force plus the outward component of the horizontal force must balance the normal component of the weight. Solving this equation tells us that the normal force equals the normal component of the weight minus the normal component of the applied force. The block is just about to slide, so static friction has reached its limiting value. At this exact condition, the friction force equals the coefficient of static friction multiplied by the normal force. Now we apply equilibrium parallel to the incline. Friction acts uphill. The component of gravity and the parallel component of the horizontal force both act downhill. At the limiting condition, these forces exactly balance. Substituting the expression for the normal force into the friction equation and then into the tangential equilibrium equation allows us to solve for the horizontal force. Using our numerical values gives a minimum force of approximately 93.7 newtons. This value has a specific meaning. Below 93.7 newtons, static friction can still adjust and prevent the block from moving. At 93.7 newtons, friction has reached its maximum possible static value. If the horizontal force increases any further, static equilibrium is no longer possible and the block begins to slide down the incline. The most important lesson from this first friction problem is the workflow. First, determine the impending direction of motion. Friction always acts opposite that direction. Then choose axis parallel and perpendicular to the contact surface. Determine the normal force before calculating the friction limit. And most importantly, only use the maximum friction relationship when the object is just about to move.